Nova One blog, and today I just want to give you a lesson on machine learning. So, machine learning is basically taking over our world. So, it's changing the way we approach complex problems in various industries. So, from image recognition to speech recognition, it's helping us achieve breakthroughs that were once thought impossible, right? Um, so I don't know if you guys have heard of ChatGPT. Pretty much everybody uses it now, but that stuff is machine learning. And I think that learning some of this stuff and being able to train the models that come up with these predictions is going to be a very useful skill and something you're going to want to look into. Just in case, Terminator or something happens, at least you know how it works, right? So at least that's the idea of it. So let's get started. I'm going to go on to the next slide. And what exactly is machine learning? So you can think of machine learning in its simplest terms as teaching computers to learn and improve from experience, just like we humans do, right? So the way they do that is they're given a bunch of data, and their algorithms basically look for patterns in the data so that it can make predictions. The machine learning model can make predictions on future pieces of data that it hasn't seen before. And they can do this without being explicitly programmed, right? So if you try to explicitly program something like this, you would run into many, many problems. So this is where machine learning comes in and helps us uh, solve these problems that cannot be done by being explicitly programmed. Right, so let's just move on. Now, suppose I'm giving you a problem where you have to write some code to classify a given fruit. Remember before I was saying that it's almost impossible to do this type of problem, to solve this type of problem without machine learning because there's so many rules that could break down. I mean, there's so many examples that could break down your rules, right? So maybe you might write some code to detect how many orange pixels are in a given image. And if there's more orange pixels than green pixels, for example, excuse me, you would go ahead and classify the fruit as an orange, right? Because there's more orange pixels. Um, Similarly, if there's more red pixels in the image, you would go ahead and classify the fruit as an apple. But what about images that are black and white, right? There's no color in them. So how do you classify the fruit then? What about images with no, apple or orange in them at all? How are you going to classify that? Uh, there's a lot of scenarios in which your rules will break down. So this is where machine learning comes in and helps us create the rules with algorithms, right? So let's go ahead and move on to the next slide. So I want you to understand some of the basics of machine learning first before we go ahead and write some code. So these things come up really often, right? So features and labels, these are like the basics of machine learning. Features are basically pieces of information that the machine learning algorithm looks at to make its decisions, right? So you can see the example below that weight of the fruit is a feature. The texture of the fruit is a feature, right? So an apple is smooth and its weight is 130 grams. Those are both features. Now, labels are the answers that we want to get from the features, right? So we want to know what these features correspond to. Is it an apple, right? Since the texture is smooth and the weight is less than 150 grams. Looks like it, that's our label, an apple. Same thing for an orange, right? You got a bumpy texture and a higher weight. So it's most likely an orange. That's basically what a label is. So let's move on to the next slide. And this is just a diagram that shows how machines learn, right? So first thing we do is we put our training data into our model, right? We train the machine learning model here. The algorithm finds patterns in the data. From there, we want to go ahead and test our model, right? Its accuracy. So how do we do that? We go ahead and put some data into it that it's never seen before, and we just want to see how close to the actual answer that it's going to get, right? So let's say, for example, I'm trying to think of an example. Let's say that you put in some training data. Let's go back to the last slide actually, and I'll show you. So let's say you put all this training data into the machine learning model, right? So it's only seen this data. But let's say you have a new piece of data now, right? So the weight's going to be 160 grams. The texture is going to be bumpy. What do you think that is, right? What do you think the model is going to predict in that case? It's never seen that data before. But based on these patterns of data, the weight being greater than 150 grams and the texture being bumpy, it's most likely going to be an orange, right? So that's exactly, what we're doing here. We're testing to see if that's the case. Does it correctly predict, what the actual label is for that specific data point? So, yeah, I already explained this part. The algorithm analyzes the test data and uses the past experiences to make a prediction. And then from there, you get a label, like I explained earlier. So, without further ado, I don't like to do too much PowerPoint slides. So let's go on to actually code our first machine learning program, right? So I'm going to exit out of this. And now we are in our Python interpreter here. I use PyCharm, but you can use whatever you want. Whatever works for you, it doesn't matter. Okay, first thing you're going to need to do is install Python. So the latest version of Python, by the way, because it's so many things that are incompatible with the older version. So you need the newer version of Python. And I will leave in a link on how to do that in the description below. And then once you install Python, you want to just create a folder here like I have. You can create it anywhere. And in that folder, this is where our project files are going to live, right? And then once you do that, you need to create a virtual environment. And again, I will leave a description or a link in the description below.
That once you create your virtual environment, you need to go ahead and activate it. And how you're going to do that is by using this command here. And don't forget to be in your current working directory. So right now I'm in intro to ML, which is my current working directory. And in there is another folder called bin. And then after that, there's a file called activate. So you go ahead and use this command here, and then your virtual environment is activated. And how you know that is by seeing this parentheses here with your virtual environment name within these parentheses. And so that's how you'll know, and you want to be able to install all of your Python packages when your virtual environment is activated. So this is just something else I wanted to add in.
And then you can get started from there. So now that you have everything installed, you have your virtual environment installed, and you have Python installed, let's go ahead and code up our first machine learning program, right? Oh, actually, I forgot. I lied. You also need to install scikit-learn. So this is how you would install it. So let's say if you're on Mac, for example, you want to install scikit-learn. You would do that here, and you would just type in this command, pip install -u numpy, and I will paste that in the description as well. And then the next command, this is actually for Windows, so if you're on Windows, this is the command you would use. It would be pip install -u scikit-learn. And I'm not going to run it because I've already installed all the dependencies. But basically, once you've gotten everything installed, you want to go ahead and import our first line of our decision tree classifier, right? So that's what I'm going to do here on the first line. From sklearn, let's import the tree here. So a decision tree classifier is basically a box of rules that helps us classify a given input of data, okay? So it'll find the patterns in there, and I think there's a graphic I can give you to, yeah, okay. So let me just get this in closer here. Hold on a minute, don't mind the technical difficulties. All right, so as you can see, this is basically an idea of what a decision tree classifier does. So it finds the patterns in the data. Remember I mentioned that our oranges usually are greater than 150 grams. So it would say, okay, is the weight 150 grams or greater? Yes. All right, we go to the next point here. Is the texture bumpy? Yes. Okay, we have an orange. It classifies as an orange. Similarly, if the weight is not 150 grams, it'll go here to this node, and then it's going to ask, is the texture smooth? No, then we have an orange. Yes, we have an apple. So you see, it's a very simplified way of explaining what this code is actually doing and how it's developing these rules. You can think of it just like this, all right? So let's go on to our next line of code. I'm going to write in the features for our training data. So this is going to be an array, and each item in that array is going to be a list of integers. So for our first data point, let's say we have 140 grams for our fruit, and 1 is going to mean that we have a smooth texture. So let me just write that key here. So 1 equals smooth texture. And then for a 0, it's going to be equal to a bumpy. Well, if I can spell bumpy texture. Okay, so now we know what our numbers here correspond to. Let's write in our next piece of training data. So I'm going to say the next fruit is 130 grams, and it is going to be smooth texture as well. Our next piece of data is going to be 150 grams and a bumpy texture, 0 there, right? And then I'm just going to put in one more piece of data. Let's say that we have 170 grams for the first feature, and then the second feature is the texture, which is going to be 0, a bumpy texture. Okay, and then the labels that correspond, well, if I could spell, the labels that correspond to each of these items in the array. So for the first one, we're going to say that is an, oh, I forget to mention, for the labels, let's say 0 is going to be equal to an apple. And then let's say that 1 is going to be equal to an orange. So this is what the numbers correspond to in our labels array, right? So for the first piece of data here, 140 grams, and the texture is going to be smooth, we're going to say that's an apple, right? Next data point, same thing, an apple. And then for this data point here, it's obviously going to be an orange. And then the next part, we're going to say that's an orange as well. So that is our training data here, the features, and then the labels for each of those features. So the next thing we're going to do is instantiate our decision tree classifier. Remember that graphic I showed you earlier? Well, this is how we're going to instantiate something that helps us create those box of rules. So decision tree classifier, right? This is our classifier variable here. Next line is going to be the same here. We're going to say colf.fit, and I'll explain exactly what this is doing. Labels. So what I'm doing here is I'm instantiating my decision tree classifier class. And then on the next line, on line 12, I'm finding the patterns in the data. That's what this fit method is doing. So it is looking through the data, finding patterns, and that's what we're using to train our model, this data here. So that's all this line is doing. And then in the next line, let's make a prediction, something the model has never seen before. We want to see what the model says about the data point. So I'm going to predict on a piece of data. So we have to put in a list, then another list, and this is going to be our data. So let's say the fruit is 160 grams and has a texture that's bumpy. So what would you think that is going to be? Oh, I put a semicolon. So what would you think this is going to be if you were to guess? It's 160 grams and the texture is bumpy. I would think it's going to be a orange, right? But let's see what the algorithm says. All right, so I'm going to go ahead and run it. Um, by the way, you have to activate your virtual environment before you go ahead and run it. So you do it with this command here, source bin activate. You have to be in your project first, your project folder. So I'm in my project folder. So I can simply do this command here, source bin activate. And you'll know you're in your virtual environment if you have this here. This is the name of your virtual environment in the parentheses. So back to running our machine learning program. By the way, congratulate yourself because this is the first machine learning program that you've written. Yeah, I know it seems simple, and it is simple to write machine learning programs. The hard part is finding the patterns in the data and what features to use, right? So let's go ahead and run this. I'm going to do Python 3 main py, and we're going to see what exactly happens. And as you can see, it output a 1 here, which means it predicted that this is an orange. So that's all there is to it. Look out for my new tutorials and everything. I'll post my blog, my website blog link in the description below as well. You can follow me on there for some more machine learning tutorials. Yeah, and I'll see you guys later.